in my first video, I would like to at least introduce the concept of how you accept inputs for scripts from the command line. Now, this is trying to get something very similar in Python that we normally expect from our command line binaries like ls or other binaries, where you can give options like -h, -a, or full-fledged options. How do we do that in Python? So let's just jump directly in and show you by example. Now, as you know, right now, most of us know that I'm using something called Python Jupyter Notebooks. If you don't know what that is, please do check it out. It's pretty cool. And it's normally used for running different snippets of code, mostly popularly used to run Python code. But what I learned later, and it's pretty cool, is I can also run command line commands. So a popular command is, for example, ls -al. The way you run this in a cell in Jupyter Notebook is you append the exclamation mark before it. And this tells you, or tells Jupyter, that this is a normal command from a terminal. So let's see, I press Shift Enter. And as you can see, in this project of mine, these are the files I've been playing with, and it'll show it to you in this output cell below. So let's see how a lot of beginners do command line arguments or arguments in Python. And it's not just beginners, a lot of senior data scientists do this as well. And what they would do is, in their simple, for example, if they are running a train script to train their model, and I'm calling it simple.py right now, what they would do is they have this main directive, and then they have sys.argv, and this gives them whatever you give in the command line as a simple list. So to make this example right, let's see how you run this, and let's see what it shows you. Now, just to clarify, I'm not running the code in over here. The code actually is in a file called simple.py. I'm just showing it to you here so that it's easy for us to see everything at one place. So you can notice over here, you call python.simple.py, and then you give all these different things at the end. And when you print the arguments, you will see that it will, for some reason, also give the name of the file, which could be cool, but it'll also give you all the different inputs that you've given for this Python script. So this is what I see very commonly, and my opinion that this is a bit cumbersome. One, you have to remember that you can't change the order. So if you are expecting something to be in order the first location, you can't interchange values over here. That would change the meaning of what you expect. The second thing is, if the biggest thing I care about is maintainability of code, and if somebody had to read this and figure out what is happening, it's very hard to know that 10 is epochs, where in machine learning world, epochs is the number of times you run your data in a loop, or you're training a loop. And what's true stand for? And what happens is your dev experience is a bit limited because you're working in the command line, and suddenly you have to look at some readme file, go there, check it out, and see if somebody wrote something about this. So it kind of lessens the development experience. The other thing is, there's no help options where you can see, I mean, this kind of flows in from the statement above. There is no help option where you can see the command line arguments right, I mean the options right in the terminal, like you'll see in the next options that I present. To note, I can still give flags like these where I can do -- activity equal to train, and there could be some kind of documentation in the name of the argument. But then in my own Python code over here, I have to then write boilerplate Python code to take the string, for example, split it with equal sign, get the key and the value. And I hope you realize that this is needless toil. It need not be done. So, having talked about the previous option, let's see what Python provides you with within the standard library. So we have another file which is simple. Now we've gone taking another file called argparse.example.py, and let's start with what it's giving you. So if you remember, I was talking about the lack of options. So let's see what -h gives you, and you immediately see that it gives you a lot of documentation, like the options you have and what it's supposed to do, the short version and the big version, booleans like debug and no debug. In case these names don't make sense to you, they are typically what you would use when you are trying to train a model in Python. So let's see how this actually happens in practice. Again, there's actually a file called argparse, but I just want to paste the code over here for you to see. And the way you do it is, it's already there in the Python standard library. There's a library called a module called argparse. And just to show how you would use it in a typical example, normally your training code or your prediction code is in a different module. So we have some module called activity, which right now just prints what values you give it to it. And yeah, but in normal cases it would be something like calling some TensorFlow or PyTorch code. So going back to the presentation, like before, you have the main directive, and then what's different is you have this parser object, and I'll explain this below. But after you add these different options using add argument, you then call this, and this is where the actual values from the command line are put into this variable called args. And then the way you get these variables is you do args or activate equal to train, where it picks up the variable from these full-fledged names or options. So you can see something very similar with args.epochs, args.debug, and so on. So let's show you some examples and show how it works and go more in detail. The first thing is to check out defaults and typecasting. So over here we have epochs, which is normally an int, and if you normally give numerals on the command line, they are generally interpreted as string. But argparse gives you this option to specify what it's supposed to be, and it'll cast that type for you in the code automatically. And you also see we are giving defaults, so you don't need to give this value. It is expected. One thing I forgot to show is that, it'll come later. So the other option is boolean. So how do you do just debug without any values? And you do that by giving the action as a boolean optional action, and you give a default. And just to clarify that this is only supported in 3.9 plus above. So let's run this code and see what happens. So if you remember the print statements in my training function, epochs is 10. Let's make it 11, and you'll see now epochs is 11. It doesn't pick up the default. It converts we're asking for the type of epochs, and it says it's an integer. You notice that we gave debug, so debug was initially false. If you see, debug is false over here, but because I said debug, it now says debug is true. I did not give profile, so it picks up the default profile, and so on. The next example, I'm just going to hide this first so that maybe it's easy and collapse all onwards. Okay. So the next example is the invalid epoch. So if you see over here, -e is a short for epoch, and we're not giving a number. So let's see what happens. As you can see, it'll error out saying invalid int value non-number. So this is great for checking your arguments. The next cool thing I want to show you is, okay, if you don't give debug, it picks it up as false. But just for the sake of completion, the way you flip it is by you adding $no to it, and this is done by argparse out of the box. You don't need to specify anything, as you can have seen over here. So like click enter, and you'll see now that debug is false. The other cool thing, which I think is pretty unique, I won't say unique, but pretty cool about argparse, is that you can give multiple values. So learning rate is normally multiple floating point values. So how do you do that in argparse? And the way you do that is you give number of hours as infinity or asterisk. Now you can even put numbers like 1, 2, and 3 over here to specify, for example, if you put 3, that there can be a maximum of 3 values given for this option. But this is how you do it if you don't want to give any kind of limit. So as you can see in this example here, I'm using -L to indicate learning rate, and I'm going to give it 2 values. And as you see over here, it picks it up as a list to give it to your training code. The other option we have is choice. So sometimes you want to curtail it to particular choices. And an additional thing I've also mentioned over here is that this is a required field. So if this is not provided, it will error out. And how do we do that? So let's say I'm giving a bad activity, it should error out, and what we get is, yes, invalid choice, choose from train and predict. The last one, if you see, is the path. Now there are two things happening over here where you're giving the type path. So you are kind of saying convert whatever string you get from the command line into a path. But the slight small thing you have to also notice that normally you have -p for path, but here I'm using -k in an ad hoc manner, not for any particular reason, because p is already used by profile on the top. So I have to manually think about these things right in argparse and specify a value. It's not a bad thing, but I'll explain why it's not preferable in general, or at least I find a slight thing to think about. So let's run this, and you see it says path equal to path to something, but it actually, the type of that variable path is POSIX path, which is this thing over here. Now, to my opinion, I think that this is really great because the big benefit here is that you don't have to install another library. You can just use something which is part of the standard library. Why I don't use it is because I still find the syntax hard to remember. Now, this could be a bit more powerful than my next option, but what I have to do as an engineer in a team is, if I have to introduce a new library, it has to be something people find it easy to pick up, and they don't have this friction. No, I have to remember this arguments. So for that reason, I generally don't use argparse. I use the next option that I have. But if you want to know more, and I still think this is a cool library, there's a link over here which gives you all the options and how to use it. So let's come to the one which I actually use in practice. Alright, if you didn't notice, you probably did, I took a break because apparently making a first video on YouTube makes you hungry during a presentation. So let's get back. We were going to tell you what the one I use right now, and that was a library called invoke. Now you can install invoke using this command, and the getting started is a great introduction to invoke. But let's do it in this notebook here. So first, no matter what you do, invoke gives you these options once you define a file called task.py. Now if you see, that file is defined here in my folder task.py, and it's copied over here for your benefit. And the idea is, if you define a task.py file like this, invoke gives you a lot of options, a lot of support. So let's look at what they mean. So -L means list all the tasks in invoke. And yeah, invoke, I use invoke primarily as a CLI script to get all my arguments, but invoke is much more powerful than that. Invoke is a task runner. What's a task runner? I mean, I don't know enough to explain it clearly right now, but hopefully that could be another video. But it's very similar to, or got inspiration from, task runners like make, which was very commonly used. And the idea is that very often, for example, when you're compiling files, you have tasks which you define a task hierarchy, that or a sequence of tasks, that this should happen first, this should happen second, these two should happen in parallel, and you use a task runner to define these tasks and to define the dependencies or the sequence, and it makes your life more easier to manage all these different sequences and parallel tasks running and so on. Well, that could be another video if you guys want it. So what does -L do? So let's look at that. And I press Shift Enter, and you can see available tasks. There are two of them, do and say hi. Let's see how that really looks in practice. So what you have to do is have the task decorator from invoke. Again, we have our activity module, which is where we put all our code. You call train again. And what I like is, all I have to do is create a function called say hi, for example, and just put the task decorator on top. And this is like a normal function, say hi, except that I have to add this context argument before. So there are two things you have to do: have a task decorator and add a context argument before, and then everything afterwards is like a normal function call. And what this will do is, if I just create something like this, it gives invoke enough information to help you invoke this task from the command line. Something to note is, in Python we can't use hyphen in words or identifiers, so we have to use underscore. But if you notice over here, invoke will automatically convert all underscores to a hyphen to be used on the command line, because generally, at least the convention is to use hyphen for command line arguments, I think. So what does this context thing do? I primarily use it just to run OS level commands like ls or echo or anything to do on the command line. But if you look at the documentation, it's really very, very powerful. There's so many things you can do. There's so many knobs you can turn and play with it. But I primarily use it to do something like this, where I create a string in Python to make my life easier, and I just give it to context.run to run that command. And we'll see an example later. Coming to do, which is my name for whatever you were doing in argparse and simple.py, and you notice there are two things that are different. One, you have to specify that learning rate is, if you remember from the previous example, can take multiple values. And the way you do it for invoke is that you give this specification in the task decorator. But other than that, and other than context, you'll see that this looks like a normal Python function, where if something is required, you give it as a normal argument. But if something is optional, you give it with a key, where you either give default values or you say it's optional, like giving none or path none. Also, how simple it is to specify something to be a Boolean option is just to give it the false value as a keyword argument in the function definition. And I won't go back up, but you'll see how easy it is to just then call these things over here. It's as easy as writing a function. So let's see how that works. Just with writing this, how does this work? So invoke has slight differences or conventions where anything general that is invoke related, you do it before the task. So what I'm saying over here is give me all the help on do, and you'll see that it gives you the doc string automatically that you've specified over here, so you get some kind of documentation, and then it gives you the options. And if you see, I didn't have to specify activity or A as my option. It automatically infers that from my command line argument, sorry, my function parameter argument called activity, and automatically says A is string and activity is string, and so on. It knows that because I gave debug as false above, it knows that this is a Boolean option. Now invoke has some kind of type intelligence, because for example I give epochs as 20 and it knows that it has to pick it up, and it knows it's an integer, and it will give you that type conversion and it will convert that for you. But I believe that this only works for simple primitive types, perhaps like integer and float, but it does not work for other custom types like path. Like how do I, and also if I'm giving none, it does not know what's supposed to be. So if I give epochs as none, for example, it would not have known that this is an integer. And even if I give a default path for path, I don't think it picks up, and I don't think it does automatic conversion according to my experiments. And you'll notice one more thing over here. In the previous example, I had to manually specify K as a random alphabet K for path, because that was conflicting with P profile. But if you notice over here, without me doing anything, it creates an option flag for you by itself. I didn't pick this up, invoke did this for you. How and what aspect it chooses, I didn't play with it too much. I'm guessing it goes from left to right and sees if that thing is already used. So P is already used here, A is already used here, so the next one which is not used is T, and I'm guessing that's how it picks it up, but don't rely too much on that explanation. So let's go back, and you'll see that you can get very similar behavior like argparse, but I just want to show a slight difference. For example, for learning rate, which is a multiple value argument, you could just give -L once and then specify the two keys. However, in invoke it's slightly different, that you have to specify each thing twice. It feels like a bit of work, but for me that's a small enough compromise that I can make right now. So let's see how that works, and you'll see very similar behavior, that it gives learning rate as 1, 2. Boolean options, if you can again see, I didn't have to specify anything in particular, but I can do things like very similar to what argparse does, where debug is true now when its default was false, and no profile flips the default and gives profile as false. And just to iterate, if I give a path as string, it'll still be string in invoke, unless you obviously explicitly convert it in your code, unlike argparse where it would help you do type conversions. So that was a bit complicated. Maybe just show something simple. So this is the other task that we had, say hi, and you see it's got my name and string, and I think I should have done this before the other one, but maybe for another video. And as you can see, invoke say hi, it requires only a name, and that's what I give. And if you remember, there was an echo in this function, and the echo says hi code plumber, and this is how it will print it on standard output. So a bit more about context object, and I don't in my 2 years of using invoke, I really haven't used context for much, and that's more on me for a lot of learning more about it. But I primarily use it as a way to run OS level commands, like with using context.run. But it also contains a lot of your global data, like values loaded from configuration files or other values that you get from the command line. And I guess it's just an interesting pattern, and I think it's a very powerful design pattern because I've seen it used in AWS Lambda, and I've seen it used in powerful languages which are not very popular, like Pony, which you should check it out. It's a pretty cool language. But I also think about maintainability and unit testing, and I feel like having an object which captures your environment and your external calls in an object like this makes it very easy for you to unit test this code if required. So just to keep in mind that this is a very interesting design pattern which I really like, and maybe you may see a use of it for you too. Now, I've already talked about the limitations, like I don't see a way of specifying non-primitive types like path. Also, I haven't seen a way of having a choice, like ensuring that, for example, if you remember, activity should only have been train and predict. But we don't have that in invoke itself. You have to do it explicitly in your Python code, which I didn't do in this presentation. Having said that, what are the strengths? So it's a full-fledged task runner, as I mentioned. So even though I haven't used that, it's nice to have that option. But what I really like about this is that it's so low friction to create tasks that can be run on the command line. And as a engineer, as a lead engineer, sometimes you have to propose tools to the team, but you can't force tools down people's throats. If you feel like they don't like it, it's sometimes not worth the effort to look for a better tool, perhaps like argparse. But in my mind, invoke has a lot of strengths, and the small places where it does not compete with argparse, that's a small compromise I'm very happy to take if I can get my team to adopt it and use it more often. And therefore, I've been using invoke for about 2 or 3 years, and I'm really enjoying it. Having said that, there are other alternatives to invoke, or the other tools are similar in a similar workspace and similar design space. I haven't gone too deeply into them, so they may be much better, but I'll just give you a brief idea in case you want to explore them later. The most popular one for command line arguments, to specify command line arguments in Python, is click. And for example, the backend developers in my company, they use click and they like click and they want to use click. So it's pretty powerful, but somehow I always found myself having some friction using it. And I just like invoke simplicity and the fact that I have this option that if I want a task runner, I can use the same structure, which I have to change and use another library. That really makes invoke more appealing to me. I don't think click is a task runner. I think it's just a pure command line argument tool for Python. There is another task runner called pydoit, which I think is actually maybe a bit more powerful in my cursory readings of pydoit, but it has a style which I find very non-intuitive. You have to not specify Python code like in invoke, but you return back a dictionary of things it can take. I have a feeling that it's much better in terms of maintainability, but I felt like I have a slight friction to introduce that, where invoke was much easier for me to introduce. I haven't introduced it yet, but that was just my opinion. Google Fire is another popular tool, and it's very similar like Click. Again, I did not go that route because I wanted the option of a task runner. If you survive so far and you're not my mother and my wife, I am very grateful and thankful that you did this, and I hope that this gave you some value, and I'm very happy if you can give me feedback on all aspects of this presentation so I can improve myself. Until then, thank you very much, and I'll see you soon.